Welcome back, Physics 20s. We just finished up part 1, looking at part 2 for lesson 1 for unit 3. That's a lot of numbers thrown at you all at once there. So next thing, you don't have this one in your workbook, I don't think, but take a second and think about this one. If we wanted to use a vector sum diagram to sketch the net force on this particular block in this particular situation, we just need to think, okay, well, is it in 1D or is it in 2D? It's definitely 2 dimensions, so we've got the vertical component, vertical being up and down, and we've got the horizontal component, that's the left and right side of things. So we can no longer really just simply use, positives and negatives. This one is kind of leading us into the next piece where we're adding by components. It's just this one, the vectors are already all in components. So if you remember how to add vectors by components, it's realistically 3 easy steps. So step 1, break into components. That's your x and y components. Again, this one kind of already done for us. So step 1, break into x and y components. Step 2 is add in components. So what we mean by that is adding x's to x's and y's to y's, and now because we're just dealing with one component at a time, so say the horizontal or the x component, we can use back to that simple reference system where we typically would call that way positive and that way negative. So right is positive, left is negative, or east positive, west negative, that kind of thing. Same thing with a vertical component, up or north is positive, down or south is negative. I might actually get rid of that because I don't want to confuse people. So step 2, add things up in x and in y, and then step 3, make a new 90-degree triangle and solve. So again, it's like 3 steps, but if you remember back to the last unit, it's 3 pretty big steps, especially that first one, breaking things in components. Fairly tedious, fairly time consuming. Make sure you're staying organized. Anyways, let's check this one out, and let's do the same sort of idea. Just the first step kind of done for us. So what I'd want to look at is I want to look at the net force in the x component, and the only forces in the x component, and we'll call it force 1 and force 2, just so we have some labels to talk about. So only thing we have is F1 plus F2. Excellent. So F1 is, let's see, 100 newtons towards the left. Because I'm just dealing with x, we're going to go back to our regular convention, and I'm going to say towards the left is negative, so that's negative 100 newtons, and I want to add to that positive 500 newtons, and we know that's going to be equal to, let's see, positive 400 newtons, or 400 newtons towards the right. Excellent. I can do the same thing for the y component, F net in the y. Let's call this one F3 and this one F4, just so we've got some labels and they're easy to talk about. So F net and the y is going to be equal to F3 plus F4. So in this case, up is going to be positive, down is going to be negative, so that's equal to positive 700 newtons plus negative 400 newtons. That's nice, easy math, don't even need a calculator. 300 newtons up. So perfect. Step 1, kind of done for us. Step 2 is essentially what we just did. So knowing that, like, for example, F1 is completely in the horizontal component, that means nothing, no part of it is in the vertical component. So we just added it to our horizontal. Next step is make a new 90-degree triangle and solve. So I've got 400 newtons towards the right. My x component, 400 newtons is my F net in the x, and then in the y component I've got 300 newtons up. Remember, if you can make this a little bit to scale, that makes life an awful lot easier, so I'm going to make 300 newtons a little bit shorter then 400 newtons. Now, if I'm adding these two together, I'm adding my x to the y. You got to remember, it is always... So making sure that we are adding correctly in 2 dimensions, we're adding tip to tail, and then our resultant is kind of where we started to where we finish, or the addition of those two. Nice to have a line drawer for this, but that's okay. My overall FNet for this entire situation is going to be going up and to the right at a particular angle. Now I believe you should be able to, at this point, solve for the net force and solve for that angle. So net force, I would use Pythagorean theorem, so c squared is equal to a squared plus b squared, and for the angle I would use tangent because I'm given the opposite side and the adjacent side. Perfect. Alright, so I've gone through and I've done step 1, breaking everything up into components. Excuse me. So as I go through and as I check this out, I've got, let's see, F2 being broken up into its y components and its x components. For the y side of things, for F2, I notice it's the opposite side. I've got the hypotenuse and the angle. So that to me means I'm going to use sine theta. Works out when I plug everything in to be a nice neat number, 350 newtons up. And my x component, using cosine, it is adjacent. So adjacent and hypotenuse is a nice easy thing to work with cosine. And it works out to be 606, actually 606.2177826 newtons. We'll just keep all of those decimals in our calculator until we're finished, don't forget. For force 1, same thing, I break it apart into the x and y components. For y component, very similar, I'm using sine. Again, that's just because that's the opposite side of the angle and I have the hypotenuse. Works out to be 321 newtons upwards, actually 321.3938, etc., etc. And our x component using cosine worked out to be 383.022216 newtons. Finally, the easiest one, these ones are my absolute favorite. F3x is 0 because all of it's vertical, so none of it's horizontal, and F3y 110 newtons downwards. Perfect. So, step 1 complete. Step 2 is just to add all the x's to the x's, all the y's to the y's. Don't forget positives and negatives for those ones. And figure out our FNet in the x and our FNet in the y. Alright, so I've gone through and I have summed up all of my x's and I've summed up all my y's. It's just at the bottom, this bluish or purplish color, remembering that I'm colorblind, please don't make fun too much. So I've got my FNet in the y is just equal to the sum of all of them, so that's F1y plus F2y plus F3y. I've got added the numbers, paying close attention to those directions, and it works out that I've got my FNet in the y component, negative 428. Done the same thing for the x, so F1x plus F2x plus F3x. Added them all up, paying close attention to directions. That one's nice and easy because it's 0 newtons, and turns out it is negative 223.2 newtons. You'll notice that I have the decimals in there because I have not rounded numbers yet, not any numbers, at least not in my calculator, on the page I have. So, next step is, let's go to the next page here, let's go that way. All we want to do is we want to add up those x's to the y's, remembering that now we're back in 2 dimensions, so we have to add tip to tail. We want to make a new right angle triangle, and we want to solve. Oh, just kidding, that one is not the 400. Let's go back and erase that. Eraser, get rid of this. The x component, pen, there we go. If we go back to the other page, was actually the 223.2 newtons. So forward, 223.2 newtons, and then my y component, again adding that tip to tail, make it a little bit bigger I suppose, is 428.6 newtons, 428.6 0.6 newtons, and then overall my net force is going down at an angle something like this, so F net is what we're looking for, and we also need that angle as well. So if I'm looking for my net force, the magnitude, I can just say F net is the square root of 223.2 newtons plus 428.6 newtons. Again, we're not really going to round that until the very, very end, so I know it's actually 223.195561, but we can round it on our page a little bit here. And that works out to be 62.5 degrees. And then when we put it all together, it's F net is 483 newtons at 62.5 degrees. And then let's just check our angle right here. So the angle is, let's see, it is touching west and then moving south. So that would be south of west as our final answer. Awesome. So it's a bit of a big question. This process, this whole idea with components is always big. But honestly, it's nothing you haven't done before, right? All we really did was switch forces for, say, displacements or velocities like we looked at last unit. You can all handle this. Make sure you're doing a bit of practice with this. Again, lesson 1 practice in your workbook is a great place to look. You've got detailed solutions on Google Classroom. The workbook itself is on Google Classroom if you're looking, as well as a couple other PowerPoints that might help you out with this. Anyways, good luck and get to it. Bye for now.